Good morning, friends. Today I am going to discuss application of an integrals. In that, I am going to discuss area under the simple curves. That is an area under the simple curves. Now, I will write an equation of a curve here. That is an y is equal to f of x. What is the area covered by this simple curve? Let me check how to find an area covered by the simple curve. Now I will take a coordinate system. Then I will draw the curve. That is this is a curve. Y is equal to f of x. Now, how much area this curve is bounded with the x-axis? This is the x-axis, y-axis. How much area bounded by this curve with the x-axis between the interval x equal to a to x equal to b? I will draw the line of x equal to a. This is the line x equal to a. This is a line x is equal to b. Okay, now I should find area bounded by this one. Area bounded by this curve with the x-axis between the interval x equal to a to x equal to b. Okay, now to find an area of this, just I will divide this total area into small strips. That is a small strip, nothing but an here. Now, like this, I am dividing the small strip. It is like a rectangle. Shape is not properly. It is a rectangle. The length is y. Length is y. Then width is I will take as dx. Now I will find the area of this small strip. Area of that small strip dA is equal to length into width. This is the area of the small strip. Like that, this total area, like this total area, I will divide it into like this so many strips. I will add the area of that small strip. Then you will get an area of this total area of a total curve bounded by with the x-axis with the interval P, Q, or S. Now, total area A is equal to area of P, Q, or S. Now that become integration from a to b. Where to where? From x equal to a to b. With the which axis? With the x-axis. That is an y dx. What is the y dx? Y dx is an area of one strip. This strip, area of this strip. Okay. Now, like this, from where to where? From a to b, I am finding. You will get a total area of the curve bounded with the x-axis between the interval x equal to a to x equal to b. Now, this is an area of bounded by the simple curve with the x-axis. Now same way, what is the area bounded by the curve with the y-axis? Let me see. Now again, I will take a coordinate system. Now I'll take a curve. This is a curve x equal to g of y. This is one curve. But then how much area covered by this curve with the y-axis? This is the y-axis. This is the x-axis. Between the interval, I will take a two line. between the y is equal to C to y is equal to D. What is the area bounded by this curve? What is the area of this one? We should find. That I will give as a P, Q, R, S. This is same way. I am dividing the curve, dividing that area into small strip. Like this, I am dividing that length is, I will taking as an x, length is an x, the width is a dy. Now, what is the area for that strip? That is a dA is equal to x into dy. This is the area of the one strip. Like this, total area I am dividing the so many strips. I will add each. That's why total area A is equal to integration from where to where? C to D. C to D. It is bounded by the y-axis. Curve is bounded with the y-axis between the interval y equal to C to D. That is a C to D x dy. This is a what? This is the area of the one strip. Integration from C to D means sum of the area of the all the strips. Then you will get an area of an total curve bounded with the y-axis between the interval y equal to C to y equal to D. Next concept is that if area is in the negative axis, negative quadrant, what will happen? How to find? Now, I will take this is the curve, equation of curve. Now I should find an area from where to where? From here to E. I should find. Now I will take this as an A1. This I will take as an A2. This is x equal to A. This is an x is equal to B. It means that A1 is a positive, you don't bother. That is a x equal to A to here, you will find. Afterwards, here to here, it is an here to here. Now, A1 is not. Total area is equal to A1, you will write as it is. But while finding the A2, area A2, that is a mod of A2. Because we can't write a negative. Area is an always positive only. That's why whatever you will get A2, you will get in the negative value because it is in the this quadrant. That's why you will get a negative. That's why you should take as a magnitude of that one, absolute value of that one. Okay, and this is the area. This is one of the concept you should remember to find the area of a simple curve. Now let's move on to the problem. This one. First one, find the area enclosed by the ellipse x square by a square plus y square by b square is equal to 1. What is the area bounded by this ellipse? Now I will draw that ellipse. How it will become? This is our ellipse. Now this point is, it is an a comma 0. This is a comma 0, point A. This is a point B, 0 comma B. This is a point A dash. This is a minus a comma 0. This is a point B dash, 0 comma minus B. Now, to find the area of this total ellipse, first I will find the area of this one. area of this. Into 4, you will get area of total ellipse. Is it right? Now, first I will find the area of that how much area bounded by the curve in the first quadrant I will find. This is 0. Now, area of ellipse, area of the ellipse is equal to 4 times integration from where to where? 0 to a. From 0 to a, 0 to a, what is it? This bounded by x-axis. This is the length, small strip I am taking. This is a small strip. The length is on y, the width is on dx. This like one strip. What is the area of one strip? That is the y dx. From where to where? From 0 to a, y dx. Now, what is the y value in this curve especially? Then given curve is x square by a square plus y square by b square is equal to 1. If I simplify, you will get a y value is equal to plus or minus b by a root a square minus x square. You will get it. Now I will fill in given integral for integration 0 to a. This is the area. Only we will take a positive value. That is a plus b by a root a square minus x square. B by a is a constant. I will take common. 4 into b by a integration 0 to a root a square minus x square. What is the integration of root a square minus x square? That is a 4b by a. That is an x by a root a square minus x square plus a square by 2 into sine inverse x by 2 from 0 to a. Be careful, whole in the application of integral. This is the only formula, it is unuseful. This only, you should remember this formula. Be careful. That is what is the integration of a square minus s square, otherwise 2 square minus x square root square. Always you will help you this formula. Integration of root a square minus x square is equal to x by a root a square minus x square plus a square by 2 into sine inverse x by a. Limit where to where? 0 to a. Now I will apply upper limit minus lower limit. That is an 4b by a, constant keep as it is. What is an upper limit? A. That is an a by 2 root a square minus a square, that is a 0, plus a square by 2 a square by 2 sine inverse. Sorry, this is not an x by 2, this is a x by a. That is a by a will, what you will get? That is a 1. This is the upper limit. Then lower limit is equal to 0. Then 0 into anything, x value 0 you should fill. 0 into anything, 0 you will get 0 plus a square by 2 sine inverse 0 by 2 sine inverse 0. What is the sine inverse 0? That is also 0. Now 4b by a, this total is 0. What is left? A square by 2. What is the sine inverse on? Pi by 2. This total is 0. Now 2 2s are 4. This 4 get cancelled. 1a get cancelled. What is left? Pi a b. This is the area bounded by this ellipse. Okay, these are the very important. Next class we will discuss some more problem on the area under the simple curve. Okay, thank you so much. Bye. Take care.